So in this video, we're going to be discussing a problem that involves how the location on the periodic table affects bonding. So part problem. The first half is we have to write the noble gas electron configuration for the element tennessine, element 117. So we're lucky that we get to do the noble gas configuration because otherwise this would be a very long problem and pretty annoying. Okay, so here is tennessine. Whenever I write the noble gas configuration, what you have to do is locate the noble gas that was last passed if you read left to right, top to bottom. And in that case, radon was the last gas. So we're going to put radon in brackets. And that means that the electron configuration for this element is exactly the same as radon. And this is what happens after radon. So we have to come and start over here at francium. So to find the energy level that you're starting on, you have to count down. So this is energy level 1, 2, 3, 4, 5, 6, and 7. Okay, so this is the S block. The S block is going to be completely full, so I'm going to write 7S2. Next, we have the F block. F blocks always run 2 energy levels behind, which means that is 5 F14. It's 14 because it's completely full. The tennessine is to the right of the board, which means that everything up to this point is full. Next, we have our D, or D block. D's always run 1 behind, so that gives us 6D10. Again, it's D10 because it's full. Finally, we're at the P block. Once again, this is going to be the same energy level as the S, so that's 7P, and I count over 1, 2, 3, 4, 5. So 7P5. Now, what I always tell my students to do is to do it in order of the periodic table, just like we did, and then to come behind yourself and put it now in numerical order. So we can use this for reference. So that means I'm going to put radon, 5F14, 6D10, 7S2, and finally 7E5. So that was the first ask in this problem. The next was to predict the formula when it forms an ionic compound with magnesium. So if you look at magnesium's location on the periodic table, it's in group 2, it has 2 valence electrons, and it's a metal, which means it wants to get rid of them. So it's going to form the +2 cation, always the +2 cation because of its location in the periodic table. Now, with tennessine, we can predict that since it's in group 7, it's going to act like another halogen, and it will form a -1. It needs to gain 1 electron to have a full octet. Now, we have magnesium +2, tennessine -1. Our pluses and minuses have to cancel one another out, which means for every 1 magnesium, I'm going to need 2 tennessines. Now, forgive me that I don't have that as a subscript. That should be Mg2s little 2, or Ts little 2.